two fractions that are the same but written with different numbers. They sometimes can be equivalent. For example, 2/3 is equivalent to 4/6. You could easily see this if you draw a diagram. Let's use two boxes and we'll split it into thirds. We can see that 2/3 looks like this. So we've the same diagram, but instead we split it into 6, like so, and we color in 4 out of the 6. What you have is the same amount colored in. So an equivalent fraction is a different fraction, but it's actually worth the same amount when referring to it as a proportion. So how do we get an equivalent fraction? We've got some examples on the left here. If we take the first one and multiply the denominator by a certain number, we'll say 2, and the numerator by 2, we end up with a new fraction, which is 2/6. And these two fractions here are equivalent, so we can put equals in between them. In fact, we can keep going, multiplying by 2 each time. So we've got equivalent here, 4/12, 8/24, 16/48, etc. And this will keep going as long as you need, and as long as you're multiplying by the same number in the top and the bottom, you could get anywhere you want. Let's try again with a 4 here. Instead, we could multiply by 3 on the top and the bottom. So you don't need to draw the arrows. So 12 over 21. Then we could go up again times 2. So we go 24 over 42. And we could notice at this point that both of these numbers, the numerator and the denominator, are divisible by 6. So instead of multiplying, which these were here, we could divide instead, as long as we do the same to the top and the bottom. So 24 divided by 6 is 4, and 42 divided by 6 is 7. So we can go back down to 4 over 7 there. And lastly, what you might see are problems with equivalent fractions. These will become more and more used as you get through the GCSE. And you might think initially here to rearrange, you might think of cross multiplying, whatever trick that you have, but we're just looking at the problem of equivalences. You might call this, we're equating it really. We're looking at the relationship between the denominators. We could see that if these are equivalent fractions as indicated by the equal sign, then this connection on the bottom shows us that the multiplication is 5 times bigger. And so knowing what we know about equivalent fractions having to be the same on the top, and this becomes times 5 as well. So at the side we could say 3 multiplied by 5 is 15. So we can conclude that x equals 15. So it's a little problem solving question that you might have with equivalent fractions.